Hello, Assalamu alaikum. Today our topic is linear regression in R, a step-by-step guide and examples. So first of all, we need to recall that what is the linear regression is. A regression model that uses a straight line to describe the relationship between the variables. So mostly there are two variables, which is the general case, that is simple linear regression. One is dependent variable and one is independent variable. However, in multiple linear regression, we uses two or more independent variables. Simple linear regression example has been taken here, and it is about that first data set contains observation about income, and which leads to $15,000 to $75,000 and happiness, which is rated on a scale 1 to 10 in an imaginary sample of 500 people. The income values are divided by 10,000 to make the income data match the scale of happiness scores. Means that $2 represents $20,000 to match it with the scale 1 to 10. And similarly, the $30,000 is written as $3. So it's some transformation we take to relate with the data set. And there is also a multiple linear regression is data sets has been given, but we are concerning about the simple linear regression first of all. So you need to download your data set first, and the simple linear regression data set, we download it. And so this is the data, income data, which you gonna use in this analysis today. So let's observe the data. This is your data sets. Is going to be open. Hello, Kenny. We have just started. We are going to consider the lecture I have uploaded on WhatsApp group, linear regression in R. And we have discussed the linear regression, in which it's a regression model which talks about the linear relationship between the two variables, dependent and independent variable. The simple linear regression uses only one independent variable. However, multiple linear regression takes into account more than one independent variable. This is a data set which relate the income groups with the happiness, and the income data is represented as $2, which is actually $20,000, as in the relation of happiness data, which started on the scale from 1 to 10. So first of all, we need to download simple regression data set, and then we will load the data into R. So I have downloaded the data. I'm just going through with these things that to get started in R, first of all, how we need to use a new file and R script we have discussed in the last classes and videos. So you can see, and I hope that you people have been practiced, and you see that to run the data is control plus enter. You already know this. So there are some packages you need to install for the to run the regression analysis, which is ggplot2, dplayer, broom, and ggpubr. These are the packages. First of all, you are required to download the data. Second, you need to open an R script and then install these packages. Afterwards, you need to recall your packages by using the library command. You already know this, so you recall the all of the packages ggplot2, dplayer, broom, and ggpubr. Why? By using library. So in next step, you are going to download and load the data into R. We have learned it by using the import data set. You use the text base of the data. It's a format of text base. So you download the income.data and import the data set. And then in the data frame, you need to see that what is our X and what is our Y. So index columns and column listing the data income and happiness in the first half that we are using for the simple linear regression. The thing that which is written biking, smoking and heart dot disease, it is written for the second data which we are not using by now. We are using the income and happiness group only. So you will see only these commands when you load the data. Click on the import button. You should appear in the environment tab. So we have already discussed in the last class that whatever data you load on your laptop, on your RStudio, it will see in the environment tab. I have shown you in the last videos. So just to check out that all things are read correctly, we use summary command. This is new to you, that you will recall the summary and bracket. So it will brings the different descriptive statistics towards the about the data. So summary income dot data. Summary income dot data means that the name of the data. Income dot data is the name of the data and summary is the command. So it will give you minimum of income and happiness, first quartile, median, mean, maximum, and the third quartile. Then this is written for the multiple regression. So I'm going to skip it by now, that hard dot data about these descriptive things, summary, you will recall on the same basis. Now you need to check the assumptions of your data, that whether they have met or not. For simple linear regression, there are a few assumptions. Number one, independence of observations, that there is no autocorrelations. There is no autocorrelation among the observations, means that independent variable and one dependent variable. So you need to the relationship. If you know you have autocorrelation within the variables, that is multiple observations of the same test subject, then do not proceed with a simple linear regression. Use a structural model like linear mixed effect models. It means that this is an assumption which should not be violated by implying simple linear regression, that there if the multiple observations of the same test subject, it means that if you have so many observations of the same individual lies in the data set, then there should not be assessed on the basis of the simple linear regression. You need to use another statistical model, which is linear mixed effect models, but we are concerning about the simple regression. So we need to use the scatter plot, or we need to use the correlation, which must lie between -1 to 1. The good correlation lies according to this some 0.3 to 0.5, and above that this is a weak correlation between 0.3 and 0.5, and the strong correlations tends to 1. So the another assumption is normality checking. We use that the dependent variable follows a normal distribution or not. We use the hist command. Hist means histogram. So we construct the hist histogram of the income dot data dollar happiness. So you must see that first of all we write the name of the data, which is income dot data is the name of the file of the data. Dollar means it's a command that we use. The variable from the income dot data is happiness. Happiness is that variable which we use from income dot data. So it's a histogram which has been come. So you must know that for a normal distribution, it must be symmetric. Symmetric means it's a bell-shaped curve, and it means that you have not of the shape of the positively skewed or the negatively skewed things. So this is written also that the observations are roughly bell-shaped, more observations in the middle of the distribution. It means that more of the observations are on the highest curve on the of the distribution, fewer on the tails. So there are few observations which are on the tails on the both sides, 0 or 6 to 7. So we can proceed with the linear regression. Number third assumption is linearity. Linearity is that the relationship between the independent and the dependent variable must be linear. You are going to imply the linear relationship, linear regression. So the independent and dependent variable must be linear. We can test this visually with a scatter plot, as I have told you earlier, to see that the data points could be described with a straight line or not. So to plot these two variables, you need to write plot. Happiness is the variable name, or it's some symbol like concurrent income. Happiness will be plotted with income, and data which we used is equals to income dot data. It means that you need to write the name of the data. So once you write these things, you will got a scatter plot. So you see that it's roughly looks linear because it seems that there is a upward trend or the linear relationship between the two variables, the income and happiness. So this check has also been done and we use the income variable. So after which you need to see that the homogeneity of the variance, homoscedasticity or the homogeneity of the variance is same, that the variance are the homogeneous or not. This means that the prediction error does not change significantly over the range of the prediction of the model. It means that the prediction error, the error which you have or you will find out after the predictions have been done through linear regression. So it will be the prediction error. It doesn't change significantly. It doesn't change very much over the range of the predictions of the model. It means that throughout the regression range of the predictions of the regression model, you should not acquire very significant or some highest values of the prediction error. So for this test, we can test this assumption later after fitting the linear models by using the residuals, finding out the residuals. So there are some assumptions for the multiple regression, but now I am discussing the linear regression. So I'm going for the analysis. Perform the linear regression analysis. So if I need to take a break from the discussion, we should go for the R, but for the online class, it's not a better idea. So we will go for the discussion first. Income dot happiness is the variable dot lm. It means that you are just writing the name of the model. So this is only the name of the variable. It's not any command. You can write any of the name you required to write over here. Then it's a prompt command. Then lm is the function which you are required to find out for the linear regression model. And you will write in the brackets that happiness is depending on the income and comma data which you have taken is income dot data summary income dot happiness dot alum. It means that the data which you have been constructed, the model which you have been constructed with the name of income dot happiness dot alum, which is actually the linear regression model, you are recalling the summary of this model by the summary command, So it will Rstudio recall it for you and you will get this formula. You can see it, that you will get the formula. That formula you imply the using the data income dot data, the residuals you got, the minimum and median, first quartile, third quartile, maximum. Residuals means the actual values and the difference between the actual values and the prediction values. And this is your model which describes coefficients. The coefficients are here are intercept, income, and the estimates you are going to use you have found is 0.20 and it's 0.71 and error is 0.08 and 0.01. So the things which we are interested in are the p-values to check out the significance of the data, the significance of the model, and also we are interested in some r square value, which is 0.74% here, and the adjusted r square value is 0.748%. So let's discuss these descriptions. So as I already told you that the estimates for the model is the value of the y-intercept in this case is 0.204, and the estimated effect of income happiness is 0.713. So you can see that the intercept value is written over here and adjacent to the intercept, and the estimate value of the um, happiness which has been come by using income, that is income on happiness, is the estimation is given as 0.713. Then the standard error values are written in the standard error, which is 0.08, and for income it is 0.01, and the t value is in this case is test statistic. So in this case the t value, the test statistic is implied, and it is for by using the income is 38.05, 38.505, and this is the value on which we construct our decision. And let's see, the p value is the probability of finding the given t statistic. So if the null hypothesis of no relationship were true, it means that we are constructing these values that there is no relationship between the two variables. This is our hypothesis. So it means that we are saying that there is no relationship between the income and happiness. So actually, we are finding it out to reject the null hypothesis that it must have some um, relationship between the income and happiness. So the final three lines are the model diagnostics, the most important. These are the final three lines, which are the most important to the diagnosis. So the p-value is 2.2, absolutely power 6, so almost it is 0. So which will indicate that model fits the data well. It means that the 0 value for the p-value, which is so small value 2.2 absolute to the power 0.16 minus 16, is actually tends to 0, and 0 is less than 0.05. It means that you will reject your null hypothesis that there is no relationship between the income and happiness. However, we accept our alternative hypothesis, which is stating that there is some relationship between the income and happiness, and it indicates that the model fits very well. From these results, we can say that there is a significant positive relationship between the income and happiness because the p-value is less than 0.001. 0 is less than 0.001. We usually use 0.05, or we can use any significant confidence interval. Seems like that 95% confidence interval or 98% confidence interval. So with a unit 0.713 increase in happiness for every unit increase in income, which has been arrived from the estimated effect of the coefficient 0.713 from the analysis which we done on R, which is 0.713 income on happiness. So 0.713 is actually a big coefficient. Mostly the coefficients, if they are greater than 0.5, they are very strong relationship and the positive relationship by using the positive sign. If there is a negative sign, it means that it is impacting the negative relationship, but it is a positive relationship. It means that when you increase your income, the happiness also increases. Now I am going to try to imply these commands on our R package. So first of all, I need to open the data set and download few packages for it. So these are the packages. And you are going to turn on R on your laptop. Before that, you must see some descriptives of the data. So I'm showing you the screen with the data descriptives. So if you see the data descriptives, the data is very obvious here that income and happiness are the two variables, and income is in terms of 3 and 4, which is $3, $4, which is equals to $30,000 or the $40,000 or something like that. Okay. So now I'm going to open my Rstudio, turn on my Rstudio. So you will see. um, Let's open it and load your file. I'm hoping that you people are listening to me. You are not here, it seems. You are waiting for the videos. You are not attending the class. Okay, so it seems that two students are here. I can see it on the pop-up. My internet is not giving me good time. So who is with me? Okay. Our studio is working really slow. So let's wait for it. Let's share the screen with you people. Our studio has been opened now. We say thank God or Alhamdulillah. So you need to open your R script. Oh God. The link which I have sent to you, is it same all of the time? The meeting link? Can you please tell me? Okay, I'm hoping that you are watching the screen of the Rstudio, and so we need to open the file, a new R file, new R script, and I need to wait for it. Okay, so if the link is same, if it's going to be disconnect in the next 6 minutes, so you need to join it with the same link. So it will be easier for me to connect it directly through my laptop. Okay, I'm hoping that it will be work now. So new file and R script we have found. So you see that this is your page. I have copy paste the commands from the source. Now I'm going to run these packages directly. What need I do? I need to select all of these so it will run simultaneously. It's going to open many scripts because I have impatient and I was just clicking on the R script. It should not be done. So there are some package which takes time to download. So if I do it for it, same time, I guess that it will take more time. So I need to wait. The second step which I'm going to do is I need to recall these packages. So I will get the commands. So you can use it by recalling the library command. Afterwards, we need to check our assumptions and the data. Our assumptions and the data. So once you have uploaded the file, you can use the summary income.data, which is the file name. So I am going to write a summary income.data, and then to check the assumptions of the linear regression, I will so ggplot2 has not been uploaded yet. Okay, now it has been done. So I need to recall the package library ggplot2, and then I will run another deep layer of package. Afterwards, I'm going back to my analysis about the assumptions of the linear regression. So the first assumption I need to make with by using histogram for the income.data. And the first assumption, you are going to check out the data for it, that whether we do not have the same case or the same income group many times. So it will occur the autocorrelation between the objects or the subjects. So meanwhile, I'm completing my commands. So the another check for the assumption of histogram normality, after which we are going to check the Scatter plot, which is the correlation between the two variables, whether the relationship lies between the two variables or not, means nothing but actually the whether they are correlated or not. So is still downloading the packages, installing the packages. So we have some time to gather our commands. The homoscedasticity, about the residuals, we will discuss it later by finding out the residuals. The smaller values of the residuals obviously are great because it's a error. You can learn it by using any of the PDF for your linear regressions, okay? So this is the whole data. So we have done with it. You can recall the data and library deep layer.